When installing parallel feeder conductors for a three-phase motor, there are several key considerations to keep in mind. These relate to ensuring safe, reliable, and code-compliant operation. The first consideration is amperage rating. Each parallel conductor must have an amperage rating that is equal to or greater than the required current per phase for the motor. The motor's nameplate specifications provide this information. It is crucial to accurately determine the motor's full load amps to properly size the conductors. Secondly is conduit size. The conduit size must be large enough to accommodate both the parallel conductors and any required insulation materials. Refer to the National Electrical Code, or NEC, or applicable local codes for specific conduit sizing requirements based on the number and size of conductors. Using the correct conduit size prevents damage to the conductors during installation and ensures adequate heat dissipation. Thirdly is current balance. It is important to ensure that the current is balanced equally among the parallel conductors. This can be achieved by using identical conductors with the same length and impedance. Unequal current distribution can lead to overloading of one or more conductors, causing premature failure. Fourthly is splicing and terminations. All splices and terminations must be made properly and securely to avoid loose connections and overheating. Use appropriate connectors and techniques that are rated for the conductor size and material. Poorly made splices and terminations are a common cause of electrical failures. Fifthly is insulation. The parallel conductors must be properly insulated to prevent short circuits and electrical hazards. The insulation type and thickness should conform to the NEC and local codes. Select insulation that is suitable for the operating temperature and environmental conditions. Sixthly is electromagnetic compatibility, or IMC. Running parallel feeder conductors in separate conduits can help mitigate electromagnetic interference, or EMI, between the phases. Ensure that the conduits are spaced appropriately to minimize inductive coupling. This is particularly important in sensitive environments where EMI can disrupt electronic equipment. Seventhly is fault protection. Adequate fault protection devices, such as circuit breakers or fuses, must be installed to protect the conductors and motor from overcurrents. The overcurrent protection devices should be sized according to the NEC and the motor's specifications. Proper fault protection is essential for preventing damage to equipment and ensuring personnel safety. Eighthly is electrical code compliance. The installation must comply with all applicable electrical codes, including the NEC, local built-in codes, and any specific codes for the motor and its application. Familiarize yourself with the relevant codes and regulations before beginning the installation. Ignoring code requirements can result in fines, delays, and safety hazards. For a three-phase, 150 horsepower, 40 degrees Celsius rise motor, there are additional considerations. Firstly, the motor is likely to require high starting currents, so the parallel feeder conductors should be sized accordingly. The starting current can be several times the motor's full load current. Secondly, the motor's duty cycle and operating conditions should be considered when selecting the parallel conductors. Motors that operate continuously or under heavy loads require larger conductors to prevent overheating. Thirdly, the specific type of autotransformer starter used may impact the current requirements and conductor sizing. Consult the manufacturer's specifications for the starter to determine the appropriate conductor size. To elaborate on these points, let's delve deeper into specific aspects of parallel conductor installations. Regarding amperage rating, NEC Table 310.15b16 provides ampacity ratings for various conductor sizes and insulation types based on temperature ratings and installation methods. When selecting conductors for parallel runs, ensure that the combined ampacity of the parallel conductors is sufficient to carry the motor's full load current plus any applicable dilating factors for ambient temperature or conductor bundling. Remember that motors often have service factors that allow them to operate above their nameplate rating for short periods. Account for this when sizing conductors. Considering conduit sizing, NEC Chapter 9 contains tables that specify the maximum number of conductors allowed in various conduit sizes. These tables take into account the conductor size, insulation type, and conduit material. When calculating conduit fill, Be sure to include all conductors, including equipment grounding conductors and control wires. Overfilling conduits can make pulling conductors difficult and can damage the insulation. Current balance in parallel conductor installations is critical for preventing overload and ensuring efficient operation. To achieve proper current balance, firstly, use conductors of the same material, size, and length for each parallel run. Secondly, ensure that all connections are clean and tight to minimize resistance. Thirdly, avoid sharp bends or kinks in the conductors, as these can increase impedance. Fourthly, consider using a conductor transposition scheme to further equalize current distribution. This involves swapping the positions of the conductors at regular intervals along the run. On splicing and terminations, use only connectors that are listed and labeled for the specific conductor size and material. Firstly, ensure that the connectors are properly installed using the correct tools and techniques. Secondly, follow the manufacturer's instructions carefully. Thirdly, use antioxidant compounds on aluminum conductors to prevent corrosion. Fourthly, torque the connectors to the specified value to ensure a secure connection. Fifthly, inspect all splices and terminations regularly for signs of overheating or corrosion. Insulation selection is crucial for ensuring the safety and reliability of parallel conductor installations. Firstly, select insulation that is rated for the operating voltage and temperature. Secondly, consider the environmental conditions such as moisture, chemicals, and UV exposure. Thirdly, use conductors with a high temperature rating, such as 90 degrees Celsius, to allow for greater ampacity. Fourthly, protect the conductors from physical damage by using conduit or other protective measures. Addressing electromagnetic compatibility. Firstly, separate the parallel conductors as much as possible to reduce inductive coupling. Secondly, use shielded conductors or conduit to further reduce EMI. Thirdly, ground the conduit properly to provide a low impedance path for fault currents. Fourthly, consider using filters or surge suppressors to protect sensitive electronic equipment from EMI. Fault protection is a critical aspect of parallel conductor installations. Firstly, select circuit breakers or fuses that are sized to protect the conductors and the motor. Secondly, coordinate the overcurrent protection devices to ensure that the smallest fault current is cleared quickly. Thirdly, use ground fault protection to detect and interrupt ground faults. Fourthly, test the overcurrent protection devices regularly to ensure that they are functioning properly. Ensuring electrical code compliance requires a thorough understanding of the NEC and local codes. Firstly, familiarize yourself with the relevant code articles and tables. Secondly, consult with a qualified electrical inspector to ensure that your installation meets all requirements. Thirdly, keep accurate records of all inspections and approvals. Fourthly, update your knowledge of the electrical code regularly to stay current with changes and revisions. For a 3-phase, 150 horsepower, 40 degrees Celsius rise motor, the high starting current is a major consideration. Firstly, calculate the motor's locked rotor current, or LRC, which is the current drawn when the motor is first started. Secondly, size the parallel conductors to carry the LRC without overheating. Thirdly, consider using a reduced voltage starter to limit the starting current. Fourthly, coordinate the overcurrent protection devices to allow for the high starting current without nuisance tripping. The motor's duty cycle and operating conditions also affect conductor sizing. Firstly, determine the motor's load factor, which is the ratio of the average load to the full load. Secondly, consider the ambient temperature and ventilation conditions. Thirdly, use Darton factors to adjust the conductor ampacity for high ambient temperatures or enclosed spaces. Fourthly, select conductors with a high temperature rating to provide additional margin for overload conditions. The type of autotransformer starter used can also impact conductor sizing. Firstly, consult the manufacturer's specifications for the starter to determine the current requirement. Secondly, consider the starter's tap settings, which affect the starting current. Thirdly, coordinate the overcurrent protection devices to match the starter's characteristics. Fourthly, ensure that the starter is properly grounded and protected from overvoltages. In addition to these general considerations, there are several other best practices to follow when installing parallel feeder conductors. Firstly, use a consistent color code for the conductors to avoid confusion. Secondly, label each conductor clearly to identify its phase and function. Thirdly, document the installation thoroughly, including conductor sizes, conduit sizes, and overcurrent protection device settings. Fourthly, inspect the installation regularly for signs of wear, damage, or overheating. Fifthly, train personnel on the proper operation and maintenance of the electrical system. By following these guidelines and best practices, it is possible to ensure a safe, reliable, and code-compliant installation of parallel feeder conductors for three-phase motors. This comprehensive approach will help to prevent electrical failures, protect equipment, and ensure the safety of personnel. Remember to consult with qualified electrical professionals and local authorities to ensure that your installation meets all applicable requirements. Furthermore, consider the long-term maintenance and potential future upgrades when designing the parallel feeder system. Firstly, provide adequate access for inspection and maintenance. Secondly, use high-quality materials and components to minimize the need for repairs. Thirdly, consider the possibility of future load growth and size the conductors accordingly. Fourthly, document any changes or modifications to the electrical system. These proactive measures will help to ensure the continued reliability and performance of the parallel feeder system for years to come. Remember that electrical installations can be dangerous if not performed correctly. Always work with qualified and experienced professionals who are familiar with the NEC and local codes. Prioritize safety and take all necessary precautions to prevent electrical shocks, fires, and other hazards. By following these guidelines and seeking expert advice, one can ensure a safe, reliable, and code-compliant installation of parallel feeder conductors for three-phase motors.